Hey, welcome. Today, we're going to dive into a subject that, let's be honest, a lot of us have a complicated relationship with math. But we're going to look at it from a totally different angle, one that swaps out memorization for pure intuition and unlocks a much more creative way to think. Does that sound familiar? Yeah, that's Stephen Colbert talking about quadratic equations, and he pretty much hit the nail on the head for how a lot of us feel. For so many people, complex math feels exactly like that, just a jumbled, intimidating mess you have to get through. And this, right here, is the big question for today. What if the whole point was never to memorize a giant cookbook of formulas, but instead to build a real gut-level feeling for how numbers and ideas connect with each other? To start answering that, we're going to go somewhere pretty unexpected. We're not starting in a high school classroom. Nope, we're heading to a Swedish kindergarten with a couple of paintings and some very, very smart five-year-olds. So researchers showed these two paintings to a group of kids, and they asked a really simple question: what's the same and what's different? The whole idea was to see how these young minds with zero formal math training make sense of the world. And one girl's answer was just incredible. She wasn't just talking about shapes. She saw an abstract connection. She realized that the shape of a line, like a mouth, could represent a feeling. She was making a connection between geometry and emotion. And the results were just fascinating. These kids were naturally doing some pretty advanced mathematical thinking. They were spotting symmetry and patterns all over the place. They even used something called transitive reasoning. Like, they figured out that since both paintings could be seen at night, maybe they were showing the inside and the outside of the same movie theater. I mean, that's the foundation of logical proof right there. So, this ability to naturally see connections leads us straight to a really powerful concept in problem solving called flexibility. And it's a simple but profound idea. There is almost always more than one way to get to the answer. And this example shows it perfectly. Take a look at this equation. 4 times the quantity x plus 1 equals 8. Okay, student B does it the way most of us were taught. Distribute the 4, solve for x. It works, totally fine. But look at student A. They see the structure of the problem and realize, hey, I can just divide both sides by 4 right away. Boom. 2 steps, and they're done. That's flexibility. So here's the key definition. Flexibility isn't just about knowing a couple of different methods. It's about understanding a problem so deeply that you can actually invent a new, better way to solve it on the fly. You become an innovator, not just a human calculator. But wait, just knowing a bunch of different techniques, well, that's not quite the whole story. Researchers found that to really unlock this kind of thinking, you need one more thing, a kind of secret ingredient. And that ingredient is connections. It's seeing how different ideas in math are all related, like understanding that one equation can be written in a million different ways that are all still equal to each other. When you put flexible methods together with that deep understanding of connections, you can solve problems in ways that are just way more powerful. Okay, so what does this actually look like? Let's take this whole new mindset and apply it to that infernal salad Stephen Colbert was talking about, the quadratic equation. Ah, yes, there it is, the good old quadratic formula. For decades, students have just been told, memorize this, plug in the numbers, don't ask why. It's basically the poster child for learning by memorization. But what if we could just toss it out? Let's take this equation right here and try to solve it using nothing but logic and our understanding of connections. Okay, so this method just uses 2 simple facts about the answers, or roots. First, we know their sum has to be negative 10. And if their sum is negative 10, their average has to be negative 5, right? So the 2 answers must be the same distance away from negative 5. Let's call that distance z. We also know their product is negative 39. So when we multiply our 2 roots together, a little algebra tells us z has to be 8, which means our roots are negative 5 plus 8, which is 3, and negative 5 minus 8, which is negative 13. And we're done. No crazy formula, just logic. You see the difference? It's huge. The old way is like following a recipe without having any idea what the ingredients do. The new way is about actually understanding the ingredients, the concepts of averages and products, so you can reason your way to the solution yourself. And here is the wildest part. This seemingly new, intuitive way of solving this, it is not new at all. The ancient Greek mathematician Diophantus was using this core idea of averaging to solve problems way back in the 3rd century. It just goes to show you that a truly great idea can be discovered and rediscovered over and over again. So, after all of this, what's the big lesson? Well, It's about making a shift in how we think, from just calculating answers to really truly thinking about the problem itself. The mathematician David Pym just said it perfectly. If we're only taught these nice, neat, step-by-step procedures, we're totally unprepared when we face a messy, real-world problem that doesn't come with a formula. The struggle to find those connections, that's where the real learning happens. And look, this is about so much more than a math test. It's about realizing that deep understanding will beat memorizing facts every single time. It's about seeing math for what it really is, a creative, logical field built on beautiful connections. And most importantly, this way of thinking, of looking for the underlying structure of a problem, that's a superpower you can use to solve any hard problem you ever face. So, I'll leave you with this final thought. Think about your job, your hobbies, your life. What's a challenge you're dealing with where you've just been looking for a formula, a quick fix, when maybe, just maybe, the real solution is waiting for you to take a step back and start looking for the hidden connections instead?